Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over the effect of a common ion on solubility. So the question is, how is solubility of an ionic compound affected when you dissolve that compound in a solution that already contains one of its ions? And so I had mentioned this in an earlier video, but let's go over this again. So if we have, for example, calcium fluoride solid and we throw that in pure water, it will dissolve to a certain extent, and we can measure the solubility of that and determine what the solubility of the calcium fluoride is going to be. Now, in a solution where you already have one of these two ions already in the solution, that would be like if I threw this in water and let it dissolve and reach equilibrium, and then I went ahead and I took some ion, maybe I took some calcium or took some fluoride ion or some salt that has the fluoride ion in there, and threw that in there and let that dissolve. So that would be kind of the same way. But in this case, it would be reversed, right? So if I already have a solution, for example, let's say I have a solution of common ion of a 0.100 molar solution of fluoride ion. Okay, so I already have that already dissolved in my container. And then I go ahead and I throw some calcium fluoride in there, and I want to know, well, how much will that dissolve? How is that going to affect? How is this common ion going to affect how much of this dissolves? Well, if we think of it in terms of the other way, right? If we dissolve this first and throw in our fluoride ion, we can think of Le Chatelier's principle and understand, well, what would happen if I understand according to Le Chatelier's principle, how would this affect? And according to Le Chatelier's principle, whenever you add a product to your equilibrium solution, right, your equilibrium system here, it's going to shift in a way that's going to undo that addition or undo the stress or undo the change that you had put into the system, right? So if I'm adding this common ion, then what's going to happen is it's going to shift to get rid of this ion. So it's going to shift towards the left, towards making more reactant, right? And if it shifts this way, that means that less of this is going to dissolve because more of it is going to become solid. So generally speaking, then we can understand the effect of the common ion according to Le Chatelier's principle, that in general, the solubility of an ionic compound is going to be lower in a solution that's containing the common ion compared to that of pure water. So it's going to be less soluble. So the solubility is going to be lower. And you can calculate the exact solubility by working an equilibrium problem just like you normally do. You would use your ice table. And of course, when you put in the initial conditions, you've got to put in whatever the amount is of your common ion. So you got to take that into consideration and use that, and then calculate what the solubility is, solving for your change and solving for the solubility of the problem of the salt. And so here I kind of started or set up a ice table to kind of show you what you would do. And so normally this would be if it's dissolved in pure water, this would be zero concentration initially, and this would be zero concentration initially. So at my initial for pure water, this would be zero and this would be zero. But since we're dealing with a common ion, we're dealing with a solution that already has fluoride ion in it, according to here, then my initial conditions would be zero for the concentration of calcium, but 0.100 molar for the concentration of fluoride. And then I would begin with the solving. So of course, this would be S because there's a 1 mole to 1 mole ratio here, stoichiometrically speaking, 1 mole to 2 moles for the fluoride ion. So here I would have my S for the change, and here I would have this would be plus S, this would be additional 2S, right? And so then, of course, this would be S for the equilibrium, and this would be 0.100 plus 2S for the equilibrium of the fluoride ion concentration. And then I would go ahead and use the equilibrium expressions to solve for S, given that I would know the solubility product constant, the KSP, for this dissolution. So I hope this is helpful. If you enjoyed this video, if you learned from this video, if this helped you in any way, please like the video, hit that like button, smash it, and also make sure you subscribe to my channel. Hit that notification bell right up there, so that way you can be notified by any other videos I put out. Put a comment down in the comment section below. Let me know what you think and if you've got any questions. I'd love to hear from you. Thanks for joining me. Have a great day.